So, solving equations. The most important thing to know is there's no one correct way to solve equations. There's always multiple ways to approach a problem. And these are just suggestions. You don't have to do these in this order. I just think it makes life easier. So, the first thing that I do when I look at an equation is see if there's anything I'm going to need to distribute. So, if I have a number on the outside of parentheses, remember there's an invisible little times right there. So whenever is inside here, every single thing is going to have to get multiplied by the number on the outside. So the first thing I do, if I can, is distribute that number out to whatever's inside my parentheses. Then if I have like terms on one side of the equal sign, I'm going to try to combine them so that I can just get each side of the equation as simple as we can before we move on. And then if I have the variable on both sides of the equation, I want to move one to the other side. And remember, when you're moving across, like to the other side of the equal sign in an equation, you need to use the inverse operation. So if it was like plus 3x, you have to minus 3x to move it over to the other side. Then, if I have all my variables terms on one side and I've combined like terms to make things simple, now I'm just going to follow those regular old steps, acting like a detective, going backwards through the problem and undoing each step in backwards order until I get back to the beginning where I have that variable all by itself on one side. Either side doesn't matter. So let's look at what this looks like. So on this one, looking out first, I don't see anything I need to distribute. So I'm going to go next to combining like terms. So on the left side of the equation, I have my 12 and my minus 7. Those are two numerical terms I can combine. So 12 minus 7 is just 5. And the rest of it's just coming along for the ride. Now, since I have x's on both sides of the equation, I need to get them together. And it doesn't matter which way you do it. I could subtract the 3x from both sides, or I could subtract the 2x from both sides. You'll get the correct answer either way. I'm going to subtract the 2x this time, although, of course, you can subtract the 3x instead if you prefer. Making sure I'm doing it on both sides of the equals to keep that equation balanced. Now 3 minus 2x leaves me 1x, which is just x. And then I've got a 5 here still. Those guys cancel on out, and I have a 1 left. So I have 5 plus x equals 1. You might know right now in your head what x is, but let's keep going. I'm going to get rid of that 5 and subtract it from both sides. And we're going to keep on going down. The 5 and negative 5 cancel, and over here I have 1 minus 5, so x is negative 4. Here I can see I need to distribute first. If you think about order of operations, we would normally start inside our parentheses or inside any groups. And this is a group right here. But since it's x minus 5, and I don't know what x is, there's no way I can simplify this any further. So since I can't do anything else inside those parentheses, I'm going to move on. There's no exponents. Now we'll multiply and divide, right? So here is my negative 2 times x minus 5. I'm going to show you two different ways to think about this distributing. The first time, I'm just going to think of this as a negative 2, because remember that 3x minus 2 is exactly the same as 3x plus negative 2. Adding a negative number is the same as subtracting a positive number. So multiplying these out, negative 2 times x is negative 2x. And negative 2 times negative 5 becomes a positive 10. Everything else is just going to come along for the ride, and we can keep solving from here. Before we move on, though, let's look at the other way to think about this. If it makes more sense to you to think of that as just a 2 that you're later going to be subtracting, you can do that, right? So if I distribute out that 2 and I get 2x here, and 2 times negative 5 is negative 10, you can do that as long as you remember you're subtracting this whole thing. The thing that people often miss is that, 3x minus 2x, simple enough, but 2x, but subtracting negative 10, subtracting a negative is the same as adding a positive, right? So you can do these either way. For me, it's easier to just remember that minus 2 is a negative 2. and multiply it right out, and then I don't have to even think about whether I'm subtracting. Some people prefer it this way, where we start with just 2 and then remember that we're subtracting. You just have to really remember that you're subtracting everything inside of that parentheses. Okay? All right, coming back to solving over here, I've got combining like terms on this same side. 3x minus 2x is just 1x, or x. And now I'm trying to get x all by myself. I bet you know what x is. All by itself, excuse me. So I have this plus 10 to get rid of. I'm going to subtract it from both sides, keeping my equation balanced, and I have x equals 4. All right, when we see problems where this little 4 that would be distributed by the parentheses is being multiplied with everything in the equation, we can start by distributing it like we would. 4 times 4 is 16x, and 4 plus 7 is 28. Or we can say, since that 4 is being multiplied by everything in my equation, I could just divide both sides by 4 instead. So I could take this here, divide this whole side by 4, and this whole side by 4. These guys cancel, and I get left with 4x plus 7 equals 11. Either of these equations is going to get us the right answer, right? So let's go ahead and solve over here. We're going to minus that 28 on both sides. We get left with 16. 16 times x. So we're going to divide by 16 to cancel that out. And we get left with x equals 1. Over on this side, we want to undo that plus 7, so we're going to subtract 7. We've got 4x here and 4. And we need to get rid of that times 4, so we're going to divide by 4. And we get x equals 1. So either way works because that 4 was multiplied by everything in the problem. Over here, notice that 3 is being multiplied by x plus 4, but not by every single thing in the equation. So although you could divide by 3 right here, you could divide this part by 3 and this part by 3 and this part by 3. If it's not being distributed across everything, you want to be careful. In this one, like, it would work because 12 divided by 3 is a nice number, but sometimes it's going to give you a not as nice number, which is fine. You'll still get the correct answer, but sometimes people get themselves lost when they suddenly have a decimal or a fraction that they weren't expecting. So in this one, let's distribute. I have 3x plus 12 minus 12 equals negative 6. I'm going to combine like terms. Positive 12 and a negative 12 is just 0. Don't even have to write it. I could just have 3x equals negative 6. And now I can ignore that 0, right? So let's divide by 3. I mean, technically I would divide 0 by 3 too, but it's just 0, right? So I've got x left over here, and negative 6 divided by 3 is negative 2. Okay. Over here, I'm going to distribute that 1/2 first before I start solving. So half of 6x is just 3x. It's 3x and 3x would make 6x. Half of negative 10 is negative 5. The rest just comes down. I can combine like terms. Negative 5 plus 3 gets negative 2. And then here I have my 3x came along. I'm going to add 2 to both sides. These guys cancel to 0, and I have 15. And 3 times something is 15. Ooh, what could it be? When I divide by 3 on both sides, I'm going to end up with x equals 5. Just to show you one other way to do this exact same problem. If I started by dividing by 1/2, that is the same as multiplying by 2. So dividing by 1/2 is the same as multiplying by 2, because it's 2 over 1, right? reciprocals. So I could have, as my first step, actually just multiplied everything by 2. If I do that, I have 2 times all of this lovely stuff, and then 2 times 13 on the other side. When I distribute this out, the 2 and the 1/2 cancel. So I just have my 6x minus 10. And then 2 times 3 is 6. 26. And now I can just keep going and solving. Oh, I could have combined like terms first. My negative 10 and 6. I didn't. It's fine. We're here. We're going to skip through these words. I'm going to add 10 on both sides. So I have 6x equals 30. And then divide by 6 on both sides to get x equals 5. This practice is called clearing the fraction when we multiply by 2 to get rid of that 2 in the denominator. You never have to solve by clearing the fraction, but it does sometimes make your life easier. For example, look at this gross problem. So many fractions. So the first thing I would like to do is get rid of these fractions. And to do that, I'm going to do the lowest common multiple of my 2 denominators. So my 2 denominators are 3 and 6, and this is a very nice one. 6 is my lowest common multiple because 3 times 2 is 6. So I'm going to take my whole equation, multiply everything by 6 so that I can get rid of these fractions in the denominator. So this whole thing by 6, this whole thing by 6. All right. 6 times 2 is 12. 12 divided by 3 is 4. I'll simplify it in a sec. 6 times 7 is 42. 6 times 5 is 30. Keeping it over 6. 8 times 6 is 48. All right, now I'm doing this in 2 steps, but you could do it in 1. And a 12 divided by 3 is 4. And over here, 30 divided by 6 is 5. So now look at this nice equation, not one single fraction in sight. I'm going to go ahead and solve it. First, I want to get the x's on one side, and then I'm going to move my numbers around. You don't have to do it in that order, though. You can always, there's so many first steps from here that are all correct. As long as you follow the steps correctly, you're going to get to the right answer at the end. I'm going to move this 48 by subtracting it. And now I've got negative 6 equals x. Now I didn't have to solve this by clearing the fraction, getting rid of that denominator. I could have minus 2/3 x on both sides, right? If I do that, I'm going to have 7 left equals, then over here I have 5/6 x minus 2/3 x, and I still have that plus 8. I could do a common denominator to turn this into 5/6 x minus 4/6 x plus 8. Sorry, my handwriting's getting sloppier. And then I have 7 equals 1/6 x plus 8. And I keep on going. I subtract that 8 from both sides. I end up with negative 1 equals 1/6 x. I multiply by 6 or divide by 1/6. Either way, and end up with that same answer. So you didn't have to clear the fraction. It's just that once I cleared the fraction, I didn't have to do any adding or subtracting of fractions. So if you prefer it. All right, what would my least common multiple of the denominators be here? And to be clear, you could use anything that they both go into. You could use 16, you could use 40, but 4 will work because 2 times 2 is 4, right? So I'm going to multiply by 4 on this side and by 4 on this side, have to multiply by the same thing. Otherwise, we are making that equation unbalanced, right? So these 4's cancel, so nice. And over here, 4 divided by 2 turns into just 2. I'm writing this on the other side, but it is still distributing. So let's go ahead and distribute that guy out. That turns into 2x, and 3 times 2 turns into 6. Now look at that lovely equation, no fractions. Let's move all the x's together. Oh, I bet you know this answer right now in your head. But let's get rid of that plus 2. And we end up with x equals 4. So just like clearing the fraction doesn't actually change the problem, right? It just makes it sort of easier for us to think about. We can also clear the decimal. And the way we do that is we look at our smallest place value that's in and we multiply by, so if the hundredths was your smallest place value, then you would multiply by 100 to cancel them out. If your tenths was your smallest place value, you multiply everything by 10 to cancel it out. And this one, I have the tenths place, ones, tenths. So tenth is my smallest place value. So I'm going to multiply everything in this equation by 10. It's just going to make them all into whole numbers instead of decimals. So 10 times 0.4 makes this 4x and makes that into an 8. 1 times 10 is 10. 0.5 times 10 is 5. And now, lovely problem. So easy to solve, hopefully. I'm going to move all of my x's to the same side. I moved to the 5x. You could have moved to the 4x. Remember, it doesn't matter. As long as you do each step correctly, we will get the same answer. I'm going to get rid of this minus 8. And now I have 9x equals 18. I'm going to divide by that times 9 to end up with x equals 2. No decimals. Here's another. Let's look for our smallest place value. Ones, tens, hundredths. I'm sorry, I said tens, but that was tenths. Hundredths, tenths. So we're going to multiply everything by 100 this time to make everything bigger. So 100 times 2 is 200. And 0.1 times 100 is going to make 10. And 100 times 0.03 is going to make 3. Stop. Use caution right here. Because we have like two distributings happening here. This part inside has this multiplied by it and has this multiplied by it. So don't do that 100 to everything. We could, let's just distribute this first before we multiply the 100 in, okay? So 0.2 times 0.3 is 0.06x, and 0.2 times 0.6 is going to be 0.12. Now that gets multiplied by 100. I'll show you why in one sec. So we have 200 minus 10x plus 3 equals 6x minus 12. Let's get all of the x's on the same side. 200 plus 3. I have 16x minus 12. This is just 203. I should have combined it earlier, but it doesn't matter. I can still do it now. It's just easy when I remember to do it earlier. Add 12 to both sides. Then we're going to have 215 equals 16x. So I'm going to divide by 16 on both sides and certainly get a number. My calculator says that's like 13.43. We'll round it right there. 8. So here's why we had to be careful with this 0.2 and this 100. So thinking about this, like if it was just some plain old numbers. So say it was 3 plus 2 times 2, and then on the outside it times the whole thing by 4. So take a minute and solve that in your head. 3 plus 2, multiply it by 2, multiply that by 4. So if I started on the outside of this and I multiplied 4 by everything inside here, I am multiplying by 4 too many times. Let's look at this. 4 times 2 is 8. 3 times 2 is 12. 4 times 2 is 8. And now when I solve this, I have 8 times 20 is 160. And is that the answer you had when you did it in your head before? I don't think it was. So let's do it starting on the inside. So we're going to distribute this 2 first, huh? 2 times 3 is 6. 2 times 2 is 4. And then multiply by the 4 on the outside. 24 plus 16 is 40. Hopefully that's the answer you had when you did it in your head the first time. The reason is this little 2, right, is going out to everything. And so if you multiply 4 by these guys and by this, it's getting like double distributed in. When really I had this 3 plus 2 in the middle, and that whole thing needs to get multiplied by these 2, by this 4 times 2, which is 8. I don't want to multiply this by 4 and this by 4. Otherwise, I'm really multiplying by 16 because these two are multiplying together. If that didn't make any sense, then just always distribute starting from the inside to the outside.